Hello guys, welcome to the another video in the series of lectures of the Advanced Compendium of Definite Integrals. In this video, we are going to solve another problem that has appeared in J once. I think it appeared in back in 90s. So it is seemingly an easy problem. So let's give a try. Let's solve it. So we are going to solve it. So we have a function fx that is defined as sin x upon x, and then we have to solve an integral of this. Okay, so first we have to think about fx. So 0 to pi by 2, I'm just going to solve it. 0 to pi by 2, fx is sin x by x, and f of pi by 2 minus x is, that will be cos x upon pi by 2 minus of x. Okay, and they both are multiplied, so we can do this. Now what we shall do is, we can see that in numerator we are getting sin x and cosine x, so we will multiply it by 2 and we will divide it by 2 also. Okay, so in numerator now we have from 0 to pi by 2. In numerator we have sin 2x, and in denominator we have 2 into x into pi by 2 minus of x. Okay, now from loving integrals, we know that if we add all of these three, we will get a constant. Therefore we can write 1 as a sum or kind of difference of these two. So what I'm going to do is, I'm going to write it as pi by 2 minus x and plus of x. Okay, so plus x minus x will be cancelled here, and we'll get pi by 2. So because we are getting a pi by 2 here, so I have to divide it by pi by 2. So I will divide it by pi by 2, that is 2 by pi. Okay, so 1 by pi by 2 is 2 by pi. Okay, let me write it more clear, that is 2 by pi. Okay, so now we can write it as, and these two to cancel here, so it becomes 1 by pi, and this becomes 0 to pi by 2, and this becomes sin x, sin 2x, sorry, and this is pi by 2 minus x upon x into pi by 2 minus x, and plus of integral 0 to pi by 2. Okay, and again this is sin 2x into x, and this x, and in denominator we have x into pi by 2 minus of x. Okay, here this pi by 2 minus x is getting cancelled, and here this x is getting cancelled. So we can again write here as 1 by pi integral 0 to pi by 2 sin 2x upon x into dx, and this is 0 to pi by 2, this is sin 2x upon pi by 2 minus x. Okay, now here we can see that this thing, if we multiply this by 2, okay, if we multiply this particular term by 2, so let's do it first. Then we have to multiply 2 in numerator also, so I'm taking 2 out. Okay, here I'm going to use King's rule once again. So by using King rule, I can write this particular thing as, I'm going to write this particular thing as 0 to pi by 2. Okay, and this is, let me, 0 to pi by 2, and sin 2x, so I'm going to write x as pi by 2 minus of x, so this will become sin pi minus x, so this will become sin pi minus of pi by 2 into pi by 2, yes, so this will become pi minus of 2x, and pi minus 2x is sin x, so this will ultimately become sin 2x, and in denominator we will have pi by 2 minus of x, that will be this. Okay, so this thing is actually equals to this. I'm going to do the same. I'm going to multiply it by 2 and divide it by 2 also. Therefore these things actually become, adding these two becomes 1 by pi, and twice of this and twice of this will become 4 times of 0 to pi by 2, and this is sine 2x upon 2x into dx. Okay, so now what I'm going to do is I'm going to take 2x as t. Okay, then dx would be dt by 2. Okay, then this thing will become 4 by pi 0 to no, so at x equals to 0 this t will be tend to 0, and at x equals to pi by 2 this t will tend to pi. Okay, so this will become sine t upon 2x is t, and this dt will become dt by 2, and this 2 will cancel this by 2. Okay, so this finally becomes 2 by pi and 0 to pi, and this is sine t upon t into dt. Okay, so and we know that variables does not matter, so I can see that this is option number A. Okay, and this is fx, so we can write this as simple fx, because sin t upon t equals to sin x upon x equals to fx, or f of t dt. So it's the same thing. So option number A is our solution. That's it. That's all for today. Like, share and subscribe. Thank you. This is option number A. So please like, share and subscribe, and please do comment if you want the PYQs of JEE Advanced of any chapters. Thank you.